Phoneme order, the order of phonemes in a sentence of glyphs on a page, is something that every natural language, and as far as I know, every Conlang as well, relies on in one way or another. But can we construct a language that doesn't rely on phoneme order at all? In my previous video, I explored whether it's possible to create a language with free phoneme order, so an unordered language, and it turns out that it is in fact possible. In this video, I'll actually construct such a language, and one that, despite being unordered, is humanly speakable. Hi, I'm Kat, and this is Lĩhusã. So, how are unordered languages possible? Well, the simple answer is that they compensate for the lack of order information by having very long utterances. In my previous video, I looked at translating utterances from an ordered language to an unordered language, and I showed that under some simplifying assumptions, the length of the unordered utterance grows exponentially with respect to the length of the ordered utterance. For example, while a 10 phoneme long ordered utterance may translate into a 31 to 41 phoneme long unordered utterance, a 100 phoneme long ordered utterance might need 36 to 46 billion phonemes in the unordered utterance to say. However, I haven't explained how one can make such a language in practice. So how do we create an unordered language that is actually humanly speakable? Let's try to convert an unordered utterance into an equivalent ordered utterance. Remember that if we have an unordered language, the only information we get is the number of times each phoneme appears in the utterance, the phoneme count of each phoneme. First, we write each of the phoneme counts in base 2. The trick now is this. If we just look at the ones place of all the phoneme counts and interpret these digits as a phoneme count, then we get a set of phonemes, in this case K and U, which we'll call a word. If we look at the twos place and interpret those digits as a phoneme count, then we get our second word made up of K, A, and T. We can continue doing this for the rest of the digits, and we stop when all the digits above that point are all 0. What we have done is convert an unordered utterance into an ordered sequence of words. Note that the phonemes within each word are unordered, as words are only defined by their phoneme counts. Also, since the count of each phoneme in each word is given by a single binary digit, it can only be 0 or 1. That is to say, you cannot have multiple copies of the same phoneme in one word. But how do we now convert this back into the unordered utterance? Well, the first word is extracted from the ones place of the phoneme counts, so to add the phonemes in this word to the phoneme count, we say it once. The second word is extracted from the twos place of the phoneme counts, so we say it twice. The third word is from the fours place, so we say it 4 times, and in general, for each word, we say it twice as many times in the unordered utterance as the previous word. This means that to convert an ordered utterance into an unordered utterance, all we have to do is just reduplicate, reduplicate, and reduplicate. This gives us an easy method of constructing unordered languages. First, construct an ordered language where each word has at most one copy of each phoneme, and words are not distinguished by the phoneme order within the word. Then, for each ordered utterance, we convert it into an unordered utterance using reduplication. We say the first word once, the second word twice, the third 4 times, and so on. And there you have an unordered language. Even if the phonemes of the utterance are shuffled around, the listener will still be able to reconstruct the ordered utterance by looking at the phoneme counts in binary. Furthermore, it's humanly speakable since it's just reduplication. So this means that constructing a humanly speakable unordered language is almost as easy as constructing an ordered language, which I honestly was not expecting to be the case. We are now ready to construct our Conlang, but for context, we need to first talk about wormholes. Around 2,000 years ago, a group of Austronesian-speaking people set sail eastward from the island of Formosa and reached a yet uninhabited island in the Nampo Island chain within the Devil's Sea, around 800 kilometers south of modern-day Tokyo. Unbeknownst to, and unfortunately for these explorers, the waters around the island are home to one end of the wormhole connecting the Devil's Sea with the Bermuda Triangle, where another island is located. Eventually, the people settled on the 2 islands with regular communication and trade between them, and their descendants today are known as the Shao people. The presence of the wormhole leads to a range of physical and psychological effects in its vicinity, including abnormal weather, large changes in the magnetic field, anomalous space-time curvature, disorientation, sneezing, strong winds, left-right confusion, adding irrelevant items to lists, procrastination, and most importantly, time permutation. With time permutation, what happens is segments of time are swapped with each other. For example, like what is happening to the sentence of this sentence. These effects are stronger the closer one is to the wormhole, and they're generally absent on the islands due to shielding from the landmass. These effects present quite a challenge to Lĩhusã when out at sea, and especially when traveling between the two islands through the wormhole. How do they communicate with each other when their utterances would get spliced and permuted? Well, the answer is that in addition to the ordered Lĩhusã language they use on land, they've developed an unordered language for communicating out at sea, Lĩhusã. Lĩhusã is a spoken Austronesian language with heavy use of affixes and reduplication and has free phoneme order. First, let's look at the phonology. There are two types of phonemes, grammatical phonemes and content phonemes. Content morphemes, so mostly verb, noun, and adjective roots, are only made up of content phonemes, shown in white, while grammatical morphemes, so affixes, are made up of grammatical phonemes, shown in blue. Because each word can only have at most one of each phoneme, separating grammatical from content phonemes makes it possible to apply any affix to any root word. Additionally, there are two phones, the glottal stop and the schwa, that are non-phonemic but are optionally inserted into vowel or consonant clusters respectively. Lĩhusã is an unordered language, and it uses the method I explained earlier to achieve this. Because of this, there's a lot of reduplication. Each word in a sentence is reduplicated a unique number of times, and I'll call this number its dupe count for short. Since Lĩhusã sentences can get very long, instead of writing out all the reduplication, for each word I'll simply write it once with its dupe count as a subscript. Lĩhusã is strongly head low dupe count. For example, the phrase black cat in Lĩhusã is Nha ongeslingel, literally cat black black. We reduplicate the modifier black once more than the head cat. On the sentence level, the default dupe count order is predicate, genitive, oblique, nominative, locative, adverb in increasing dupe count. For example, the cat eats the fish in Lĩhusã would be Macha doslichu ongia, literally eat, predicate, fish, oblique, cat, nominative. Now, the main function of reduplication in Lĩhusã is to replace phoneme order in other languages, which we call syntactic reduplication. But there are also other uses which we call morphological reduplication, and this is applied at most once per word. Nouns in Lĩhusã are mandatorily marked for plurality by reduplication. So the cats eat the fish would be this, where ongia, cat in a nominative, is reduplicated 3 times instead of 2. Adjectives in Lĩhusã can be intensified, and this is marked using, again, reduplication. So a very black cat would be Nha ongeslingel, literally cat black. Verbs in Lĩhusã are marked for aspect, and the imperfective aspect is marked by, you guessed it, reduplication. And on the topic of verbs, morphosyntactic alignment in Lĩhusã is done using, man, you are so good at guessing, Austronesian alignment. How this works is the topic of each sentence is marked with a nominative case, and the semantic role of this topic is marked on the verb with a voice marker. The rest of the noun phrases have their semantic roles marked on the noun by the respective case markers. For example, in our sentence earlier, the cat eats the fish, the nominative noun cat is the agent, and so the verb to eat is marked with the actor voice affix m. There are 4 voices, actor, goal, locative, and benefactive, which mark the agent, patient or goal, time or location, and benefactor or manner or instrument respectively. You'll be pleased to know that these do not correspond nicely to the 4 cases, nominative, oblique, genitive, and locative. Oh yeah, the actual affixes look like this. The voice markers also mark for tense and mood, and the case markers have personal and non-personal forms. And before I forget, here's a list of some other affixes in Lĩhusã. Okay, you might have observed a problem with this much reduplication. Applying morphological reduplication can make a word's dupe count collide with the dupe count of another word. This is usually fixed by deduplicating the word that it collides with. For example, while black cat is literally cat black, for the plural black cats, we would reduplicate cat. But then the 2 words would have the same dupe count, so we deduplicate black and get cat black, or in Lĩhusã, Nha ongeslingel. The procedure is then to first perform reduplication, both syntactic and morphological, and then deduplicate words with no morphological reduplication until there are no clashes in dupe count. This is always possible, and I'll leave the proof of this as an exercise for the viewer. However, deduplicating can sometimes lead to ambiguity, in which case one could instead reduplicate all the words with a dupe count higher than the one we want to reduplicate in order to resolve the overlapping dupe counts. The strategy roughly doubles the length of the sentence, so deduplication is strongly preferred. Now, let's talk about discourse. While shuffling the phonemes within an unordered utterance doesn't change its meaning, merging two unordered utterances together does. To prevent this from happening, speakers leave big gaps of silence between sentences on the order of 10 seconds. But then this makes it hard to tell if someone has finished talking or not when a sentence is finished, so it's common for speakers to produce one or two dental clicks at the end of the utterance to signal that they're done talking. Okay, let's look at a few example sentences. First, we have unshakhalev no shao ofaling. The predicate here is the goal voiced marked verb unshakhalev to open in the non-past, and we see that it occupies the lowest dupe count. The nominative marked noun is ofaling, door, so it is the patient, as the verb is in the goal voice. The word no shao, person, is in the genitive case and has dupe count right above the verb, so it must be the agent. So the sentence means the door is opened by the person, even if you pronounce it as nga 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 fa 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 wa ha sha sha la 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 ya na na shi I a u o u, or o la a u shi I o la a u shi I ha shi I nga 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 o fa wa o shi ya na shi. Now let's look at some examples of reduplication. If we want to say the person speaks, that would be mia o xiao, so speaks 0, person 1. If we now want to say the people chatter, that would be the same sentence but with both words reduplicated. We don't get any dupe count conflicts, so that's it, simple. However, if we now instead want to say the people chatter about the woman, that would be this. We see that tovaia, woman, in the oblique case has a lower dupe count than the predicate mia, to speak, which is the opposite of the default dupe order, so the predicate must have been reduplicated. Also, o xiao has a dupe count of 3, we skipped the dupe count of 2, so this word must also have been reduplicated. As a result, we recover the meaning the people chatter about the woman. Okay, but what if we want to add another clause to the sentence, say the people chatter about the woman, then the person sees the sad woman? Well, we can simply add the second clause to our first clause, but occupying a higher dupe count. Although we do see that the dupe count of 2 is unoccupied, so we can deduplicate the second clause so that the dupe count of 2 is occupied, making the sentence more compact. However, this sentence is still quite long. There are 8 distinct words, and if we count the reduplications, that's 255 words in total, so that's not great. We can split up the two clauses into 2 separate sentences instead to get 11 and 31 total words respectively, which is a lot more practical. So let's see, we've covered the phonology, reduplication, Austronesian alignment, some example sentences. I feel like we're missing something. Yeah, you're right, the writing system. Since the phonemes of each sentence can be ordered any way you want, the shall take advantage of this with the unordered writing system for Lĩhusã. Also, because it's only used out at sea, Lĩhusã isn't usually written down. When it is written down, it's mainly for ornamental or artistic purposes. Because of this, Lĩhusã writing has evolved to become a blend between art and phonemic representation. There's a lot of freedom and variation in the writing style, and so I'll be presenting just one style of writing. Let's write our example sentence from earlier. The door is opened by the person. First, we draw a box, and inside the box, we draw a picture that represents the contents of the sentence, like in a panel of a comic. Next, we add case markers. These are shapes placed along the lines in the drawing. In the sentence, we have the word for door in a nominative case, and we say it 4 times, so we draw 4 diamond shapes along the edge of the door. Similarly, the word for person is in the genitive, and we say it 2 times, so we draw 2 squares along the person's outline. We now also add the rest of the grammatical affixes, which are represented by characters that are usually placed on the object they're attached to. In this case, we only have the non-past goal voice marker on the verb to open, which we write with this character, and let's put it on the hand since that's where the opening is done. And we're technically done with the writing. When reading this panel, you can see from the drawing that the door is being opened by the person, and the grammatical affixes and how they're placed confirm that. But oftentimes this is not enough. For example, it can be ambiguous whether the verb is to push or to open or to touch, and it's also a problem if your sentence cannot be represented visually very well. This can be fixed by adding content characters. Content characters can be used in 3 ways: logographically, diphonemically, and in compounds. For example, let's look at this character. By itself, it can be used logographically to write the root angel, meaning mouth. It can also be used diphonemically to represent 2 content phonemes, in this case la. Note that there are some diphonemic combinations which have multiple characters that can be used to represent them. Because Lĩhusã is unordered, the order of the 2 phonemes is irrelevant, so there are 18 content phonemes, choose 2 equals 153 diphonemic combinations. Also, if there is an odd number of content phonemes in a word like had, then we can represent it using, for example, characters for da and ha. When there is an overlapping phoneme, we know that only one copy is meant. Now, the mouth character can also be used to make compound characters, such as this one composed of the characters for mouth and taro, which is used logographically to write the root had, to eat. Or this character composed of mouth plus tooth, which is used to write the root hash, to bite or to sting. Characters can also be combined without changing their meanings. These are called ligature characters. For example, combine Lĩhusã, turbulent sea, and Lĩhusã, an affix meaning pertaining to, and we get this ligature character for the Lĩhusã language, the language of the turbulent sea. So let's add in the content characters, and that's the written sentence done. What's great about writing out all the content phonemes is that characters can be placed wherever you want and the meaning stays the same. Remember, Lĩhusã is unordered. Heck, you can even draw anything you want and the meaning still doesn't change. The shall love to do wordplay with this. We can write out our other example sentences, and if we want to put them after this sentence, we can place them linearly, or we can also arrange them together like a 4-panel comic. Now that we finally have a good overview of the language, to finish off this video, I'll read you a story of the Shao people in Lĩhusã. Khasuvi, meaning the sea snake. To give you an authentic experience of time permutation, I flew to the Bahamas, took a boat to the Shao Islands, and recorded myself reciting the story while sailing through the wormhole. A written form of the story will be shown on screen along with a gloss and a translation. So, here we go. Hua ohutal ohutal. Mia doshik on khasui on khasui on khasui on khasui e khasui. Moach khasui och khasui oui. Nhau ship. Đi vào nhau ship vào đồ xe ship vào đồ xe ship vào đồ xe ship vào đồ xe ship trong hash 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 boogie 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 boogie. Đi nhau khilio tosuk on khubal khubal on khubal on khubal on khubal on khubal khubal on khubal on khubal on khilio khubal on khubal on khubal on khubal on khubal on pilha on pilha on pilha on pilha on pilha on pilha pilha on 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 pilha pilha on 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 pilha ribu 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 ribu. Ribu Wuha, Kenyasha, Budovuthi, Dovuthi, then Oladan, Hadi, then Odovuthi, Oladan, 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 Oladan. Doniechać do ich do ich. Salada stoali salada stoali 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 hash nie hash 现在都是荷兰，都是荷兰，是荷兰，是荷兰，都是来小孩，小孩，小孩，小孩，小孩，小孩，小孩，小孩，多了的多了的多了的多了的多了的多了的多了的多了的多了的多了的多了的多了的多了的。多了的多了的多了的多了的多了的多了的多了的多了的多了的多了的多了的。多了的多了的多了的多了的多了的多了的多了的多了的多了的多了 no hitu di no hitu 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 现在的和现在的和都还都还都还都还小有小有小有小有小有小有小有小有拖的还拖的还的还拖的还拖的还拖的还拖的还拖的拖的还拖拖的还拖拖的还拖的还拖的还拖的还拖的还的还拖的还的还拖拖的还拖的拖的还拖的还拖的还拖的还拖的还拖的还拖的还拖的还拖的还拖的还hash to the hash to no hitu no hitu no hitu the hash to no hitu 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 tu oingabu trom oli mangabu tio o trom mangabu ngabu usa 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 oh oh itu neta 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 da lihu no itu no oh lihu no itu ya ke doi hu shi we mo hu we mo hu we Matthew no hadi has to hadi do hisu no hisu has hisu don't has no hisu no has don't has ushi don't has don't has ushi don't has ushi Sangi Matthew Sangi ten has evalum nehu